What's up, guys? This is LeetCode 235, lowest common ancestor of a binary search tree. Given a binary search tree, find the lowest common ancestor of two given nodes in the BST. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. Given a binary search tree as this image is showing us, we can find where is the lowest common ancestor of nodes 2 and 8, which is 6. Another example, what is the lowest common ancestor of 4 and 3? Is 2, because 2 is the closest node above 3 and 4, is the closest node of both 3 and 4 that is above both of them. And we can also check an example where a node can be a descendant of itself, where what is the lowest common ancestor of 2 and 4? So the lowest common ancestor of 2 and 4 is 2, because within this subtree, 2 is the closest node that has both 2 and 4 in its subtree. And as we are working with a binary search tree has an invariant which says that every node in the left side of a node has its value less than the current node, and every node on the right side of a node has its value greater than the value of the current node. So you can check here, every node in the left side of 6 is less than 6, and every node on the right side of 6 is greater than 6. And this is true for every subtree in a binary search tree. You can also check that every node on the left side of 2 is less than 2, and every node on the right side of 2 is greater than 2. So by knowing that, we can write a solution for this problem, going through all the... We actually don't need to go through all the nodes in this tree. We just need to check if the current node is greater than both P and Q, or if the current node is less than both P and Q. And if not, this means that P and Q splitted in different branches, into different branches. Like here, 2 and 8 are the nodes that we are looking for its lowest common ancestor. So I will check P and Q is greater than 6, no. And 2 and 8 are less than 6, no. So means that 6 is the lowest common ancestor of both 2 and 8. So yes, we are going to follow these checkings to find the lowest common ancestor in a binary search tree. Let's see how can we code this. So we are going to navigate through these nodes using recursion, and we don't need to create another function. We will use the lowest common ancestor function to do that. So as I said before, we just need to check if the node that we are looking for is greater or less than the current node, and we can do that by simple let me see, we can do that by simple actually checking if p.val is greater than root.val, and also if key.q.val is greater than root.vol. If that's true, means that the node that we are looking for is on the right side of the tree. So we can start our recursion here by calling again the lowest common ancestor function with root.right and PNQ again. So if that's not true, we can do the opposite checking and validate if p.vol is less than root.vol, and also check if key.vol is less than root.vol. If that's the case, we are gonna do the opposite of this call here and call again lowest common ancestor using the left side of the tree. If none of these check-ins are true, we can assume that the current node is the lowest common ancestor. So we can just return root. Yeah, if we don't have any typo here, this seems to be a solution for this problem. Let's try to run the code. Yes, let's try to hit submit. That's it. The time complexity for this solution is big O of 8, where 8 is the height of the tree. Thanks for watching.